Astronomers tracking the interstellar comet 3I/Atlas have continued to report a remarkably stable flight path as the object makes its way through the inner regions of the solar system, a detail that has significantly reinforced confidence in current planetary defense models and orbital prediction methods. According to NASA, which confirmed its latest findings on October 30th, 2025, the comet passed Earth's orbital distance without any detectable change in its velocity, direction, or overall behavior, traveling at a steady and exceptionally high speed of 68.3 kilometers per second. 3I/Atlas has maintained its predicted course since the moment it was first identified in July 2025, putting to rest a wave of online speculation that suggested the object might unexpectedly veer toward Earth after passing close to the Sun. This speculation had been fueled by social media discussions, misunderstandings about gravitational dynamics, and several viral posts predicting catastrophic scenarios that were not supported by any scientific data. NASA, alongside the European Space Agency (ESA), has repeatedly emphasized that there has been no deviation in the comet's motion, and that its trajectory has remained fully consistent with the original solutions calculated by astronomers worldwide. The comet's closest approach to Earth is expected to occur on December 19, 2025, at a safe distance of approximately 268 million kilometers, which is roughly twice the distance between Earth and the Sun. In astronomical terms, this is an extremely comfortable margin, and it means the object poses absolutely no threat to Earth or any other planet. Furthermore, data from ESA and NASA's Jet Propulsion Laboratory confirm that even after accounting for gravitational influences from the Sun and nearby planets, as well as the heating effects experienced during perihelion, the object's speed and orientation remain unchanged. Astronomy Vibes, an independent space science organization that shared its orbital model publicly on X, formerly Twitter, also displayed a stable hyperbolic trajectory that perfectly matched the predictions made by official space agencies. The consistency across multiple independent calculations has strengthened scientific confidence that 3I/Atlas is behaving exactly as expected for an interstellar visitor, an object that is not gravitationally bound to the Sun and therefore follows a hyperbolic escape path rather than looping around the solar system like typical comets. Earlier online speculation had suggested that the comet might suddenly alter its course after reaching perihelion, the point where it passes closest to the Sun, due to possible outgassing events or unpredictable activity on its surface. While comets within our solar system can sometimes exhibit slight changes in motion when solar radiation causes jets of gas or dust to erupt from beneath their crust, such effects are usually very small and easily measured. In the case of 3I/Atlas, however, astronomers have found no evidence of such behavior strong enough to influence its trajectory. Its velocity has remained constant, and any natural activity that may occur on its surface after being exposed to heightened solar radiation does not appear to generate enough force to produce meaningful changes in its orbital path. The fact that the comet has demonstrated such stability further confirms the reliability of long-term orbital modeling, even for visitors arriving from outside the solar system. Scientists have pointed out that this behavior is not unusual. Previous interstellar objects, including the well-known Oumuamua, discovered in 2017, and the second interstellar visitor 2I/Borisov, detected in 2019, also followed hyperbolic trajectories that ensured they would eventually exit the solar system permanently. These objects come from distant ancient star systems, and their immense speed, combined with their unbound orbit, indicates that they were likely ejected from their home planetary systems due to gravitational interactions long before they ever approached our Sun. Once such an object passes through the solar system, it is simply carried onward into interstellar space, continuing a journey that may have begun millions or even billions of years ago. 3I/Atlas fits this category perfectly, and its predictable motion helps scientists draw parallels with previously observed interstellar travelers, while also offering a new opportunity for comparison and study. Although 3I/Atlas poses no danger to Earth or any other planet, its ongoing passage is creating tremendous excitement within the scientific community. Telescopes around the world, ranging from large ground-based observatories to space-based instruments, are currently monitoring the object in order to study how it reacts to solar heating. Observers are focusing on details such as changes in brightness, the presence of gas emissions, and the development of any coma or tail structures. These aspects can reveal important clues about the comet's chemical composition and internal structure. Because interstellar comets formed in environments completely different from our own solar system, their materials can offer a glimpse into the chemical building blocks present around other stars. For example, if scientists detect unfamiliar compounds or unusual behaviors, this could help refine theories about how other planetary systems were formed and what types of environments existed in their early developmental stages. ESA scientists often describe interstellar objects as time capsules that carry preserved material from the ancient, distant regions where they originated. Unlike comets native to our solar system, which experience repeated cycles of heating as they orbit the sun, interstellar comets may have spent vast lengths of time traveling through extremely cold, empty space. This means the materials on and within them remain relatively unchanged, offering scientists a rare and valuable snapshot of primordial matter from beyond our solar system. Observing how 3I/Atlas behaves under the sun's heat, therefore, helps researchers understand how such untouched material responds to new environments. These observations also provide data that improve planetary defense models, particularly when it comes to predicting the paths of fast-moving, unfamiliar objects arriving from interstellar space. NASA has restated multiple times that the current trajectory of 3I/Atlas does not pose any threat to Earth, Venus, or Mars. The comet's minimum separation from Mars occurred in early October 2025, passing safely at a distance that ensured no gravitational influence of meaningful significance. Similarly, its alignment with Venus, scheduled for November 3, 2025, is expected to maintain a safe separation of approximately 97 million kilometers. These distances further demonstrate how securely the comet's path is understood and how minimal its interaction with the planets will be. Even as it moves deeper into the inner solar system and then eventually back outward, it remains too far from any major body to be affected in a way that might alter its predictable escape trajectory. Its hyperbolic orbit ensures that once it completes its passage by the Sun, it will gradually accelerate outward and return to the vast expanse of interstellar space, continuing a journey that stretches across unimaginable distances. At the same time, the scientific value of observing 3I/Atlas cannot be overstated. Every interstellar visitor offers a rare chance to study material from beyond the Sun's influence, and each instance expands human understanding of the galaxy. Researchers hope to gather data on how its nucleus behaves when warmed, whether it sheds dust or gas in unusually high or low quantities, and whether its brightness fluctuates in ways that differ from solar system comets. These details may eventually help astronomers determine whether 3I/Atlas resembles 2I/Borisov, which behaved much like a typical comet, or whether it shares characteristics with Oumuamua, whose unusual shape and motion sparked years of debate about its origin and nature. Comparing these objects allows scientists to build a more complete picture of how diverse interstellar wanderers can be. As 3I/Atlas continues its approach toward its December closest past distance, observatories in multiple countries are collaborating to ensure that data collection remains consistent. International cooperation has become essential in studying objects of this nature, as no single telescope can continuously monitor the comet throughout its entire journey. By coordinating observations around the globe, astronomers can maintain nearly uninterrupted coverage, capturing changes in brightness, motion, and surface behavior as the object progresses. This coordinated effort also supports the improvement of predictive models, which in turn enhances planetary defense systems that track potential hazards in space. In summary, 3I/Atlas has proven to be a stable and predictable interstellar visitor whose flight path matches the expectations of astronomers with remarkable accuracy. Despite the concerns raised in online discussions, scientific observations have consistently shown that the comet maintains a safe trajectory far from Earth and the other inner planets. Its behavior reinforces confidence in orbital tracking technology and provides a valuable scientific opportunity to study matter from beyond the solar system. As it continues its journey through the inner solar system before eventually returning to interstellar space, scientists remain focused not on fears of danger, but on the wealth of knowledge it brings. Knowledge that deepens humanity's understanding of the galaxy and the many worlds that lie far beyond our own.